Right, so we're going to do solve absolute value functions. We're not only going to solve them, we're going to graph as well. So maybe I'll talk and graph absolute value functions. And to solve absolute value functions, we've got to split it into a positive and negative parts. They'll become a lot more evident as we go along the video. So let's give this a go. Okay, what is it? Well, absolute value is essentially that we want everything inside the absolute value symbols to be positive. So minus 5 is equal to 5 there. But also positive values equal 5. Okay? So one thing that we can use this for is like distance. It doesn't matter if we've got distance in the negative area or the positive area, or direction I should say. You're still only 5 meters away from me. Doesn't matter if you're 5 meters to my left or 5 meters to my right, you're still 5 meters away from me. And that's what absolute value means. So in this case, if we've got minus x within the absolute value symbols, it equals x. Actually, it shouldn't be. I should rewrite that. So minus x in absolute values is just going to be positive x. Okay, so fix that one up. Okay, so what does it look like? So what I'm going to do is I'm going to do a quick table of values and let's pop it in. So y equals, so if x is negative 2, so I'm starting with that one there. I'm going to maybe choose a different color pen, maybe this one, yep. So if x equals negative 2, what does it equal? Well, if y equals minus 2, then that we just saw that that equals 2, so that equals 2 there. If y equals 1, well, that's just going to be equal to positive 1. 0 will still be 0. Now, 1 will be just 1 from what we saw over here. 2 will just be 2, and 3 will be 3. Okay, so let's graph it. Remember, these are points. So minus 2, 2 is going to be there. Minus 1, 1 is going to be there. 0, 0 is going to be there. 1, 1, 2, 2. 3, 3. And then we can just keep going. So if I just draw a straight line amongst all those, let me choose that color pen. So it looks like this and like that. Okay? And I could probably get more accurate. Let me try get it more accurate. So I've got to go try. Yep. Yeah, that's a bit better. Okay, so it just looks like I'm going to highlight it because it doesn't look that good to me. Let's get green. So just up there and up there. Okay, so it looks like a V shape. And in actual fact, what it is, it's a combination of these two lines. It's a combination of y equals x and y equals minus x. Notice that the y equals x line will go that way and the y equals minus x goes that way. Except we're always in what? We're always in the positive direction. Do you see that? Okay, so that's what an absolute value graph looks like. Okay, let's explore this a bit further. Now we're starting to get better at graphs and things like that. So what does this graph look like? Oh, well, if we use the same logic that we've been using, it's going to be just like y equals the absolute value of x, except we're going to go down 3. Okay, let's try it out using Desmos. Now I'm going to try something that I saw that we could do. So I'm going to bring up Desmos here, and I'm going to go y equals absolute value of x, and that's what we got in the previous slide. Now I'm going to go minus 3 and see what happens. It drops it down 3 times. So hopefully you're seeing that because I can't draw on that side of the Desmos page. So I'm going to go back to my my page here and I'm going to draw it. So it's going to be the same as this graph except it's gone down 3. So the same things that we've been doing with other graphs still apply to these weird new graphs that we've seen. So it's going to go minus 3. I'm just going to copy what it is from Desmos. Okay. So let's do it. Minus 3, 3 there. Actually, I'm going to do this one more time. So I'm going to minus 3, 3 all the way up. Yep. So let's do that. And then this one's going to go like that. Okay. And that's not accurate. You can see how it looks like on Desmos and things like that. Okay. Now, for this second one, I actually can combine both of them. Yeah. For this second one, so I'm going to highlight this one. What happens when we had something normally in graphs, we got x minus 3, what happened to the graph? Often it moved to the right 3 times, okay? So, like I'm talking about, remember the graph, like if you got y equals x minus 3 squared, well, it's the same as y equals x squared, except it's moved to the 3 to the right. Now let's try if that happens here in this one as well. So I'm looking at the Desmos part of the video now, and I've got y, and I'm going to put the absolute value function notation as well. Oh, actually, I'm not writing it properly. Y equals x minus 3, and as predicted, all it's done, it's moved the y equals absolute value of x function to the right 3 times. Let me put all 3 of them in, the one that we've got there. I'm going to put y equals absolute value of x in. And there it is. And then I'm going to put my final one in, which is y equals, and what was that one we did before? Absolute value of x minus 3. So we've got all 3 graphs in there. Now I'm not going to draw it in there because I feel like it's going to take too much time of this video, but hopefully you can see what's going on. Then I'm going to go take away of Desmos, and I'm going to go to this one. All right, so how do we solve these? Well, there's one way that I want you to solve it. There's a couple of ways we can do it, but I'm only going to teach you one, okay? First of all, we just do the positive side. So I'm going to go x equals 6, done, all right? But then we have a second solution, or we're going to do the negative of what's inside of here. So I'm going to go minus x equals 6, therefore x equals negative 6. So we have solutions of negative 6 and 6, and hopefully that makes sense because that's what we talked about right here at the beginning in this one here, okay? In this one here, we saw that negative 5 equals 5, negative x equals x, okay? So let's go back to that. Now for the number 2, it's going to be less obvious, so just follow my logic. So it's going to be the same thing. Positive x minus 3 equals 9, so exactly what we look at. So therefore x equals 12. Okay, so that's one answer, but we have 2 answers. Or, and now look at this. This is what I want to see for everybody who's working out. Bracket x minus 3 equals 9, but it's going to be negative. Okay, remember we're going to have the positive and the negative, and remember we have the ski jump here. So we've got minus x plus 3 equals 9. So negative x equals 6. So therefore x equals negative 6. So they both give us the same answer. Now, let's put this answer here into this question. So it's going to be negative 6 minus 3. That's going to give us an answer of negative 9 in here. And we know that equals 9. So it works. It really, really works. So let's do this final example. Okay, let's just do the normal thing. So it's going to be 7x minus 3 equals negative 11. Now we just solve for x. 7x equals minus 11 plus 3. I think that's minus 8. Therefore, x equals negative 8 on 7. Okay, so we're getting the right answers. Hopefully, I'm doing it right. Or we have a second solution where we have to do whatever's inside these absolute values. We're going to do the negative of it. So let's go minus 7x minus 3 is equal to negative 11. Remember, we have to ski jump it. So that's going to be minus 7x plus 3 equals negative 11. So minus 7x equals minus 14. I'm going to get rid of both those negatives. Therefore, x also equals 14 over 7, which should equal 2. Okay, so we have two solutions for each one of these equations. So here's one solution from here. Here's our second solution. We've already looked at number 1. Here's one solution for here, and here's our second solution. All right. Hopefully that makes sense. That's the end of this lesson. Peace out.